So the danger shield has arrived, and I thought I'd have a go at videoing me putting it together. Not that you, Gabriel, really need to see it put together, because yours is already together because I made it before I even knew it was going to be yours. But anyway, so we will unbox it, as they say. Comes in this neat little spark fun box. Inside we have a bag of various bits and pieces. We have these big sliders, which have got two prongs one end and one prong the other end, and we've got this little chip, and we've got the 7 segment LED. No, it's more than that. 1, 2, 3, 4, 5, 6, oh, 7 segment LED stuck into a piece of foam simply so that the pins don't get bent. And 2 more sliders, and we've got PCB and the box on one side. So clearly the sliders go here, and let's see what we've got in our box of bits, in our bag of bits. We have got quite a few little resistors, and we've got these headers, as they're called, and soldering those is a bit delicate job, as we will see later on. We've got 3 big buttons, 1, 2, 3, and 1 little button, and we've got 1 transistor and 1 light sensor, and 1, 2, 3 LEDs, and a whole bunch of resistors and 2 capacitors. And one of the things we've got to do is work out what the values of these resistors are. Oh, we've also got this buzzer. So it's always a good idea to put the small components on first, so those will probably be the resistors. So I'm just going to stop the camera now while I have to sort out the resistors, because it's quite difficult for me to see what I'm doing as I'm behind the camera. Okay, well, one way of finding out the values of resistors is to look at the colour code on the band, but these are so tiny it's actually quite difficult to see, and it requires you to either memorise or have a table of the colour code. But here's another clue. If we look at the board here, 1 resistor goes there. You can tell it's got a little sort of rectangle, and inside it says 1M, that's 1 megohm. And then here it says 330, 330, 330, 330, and over here it goes 330, 330, 330, 330, and 330, 330, 330, 330. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 330 ohm resistors. So never mind colour, if I can find that 11 are the same, they're probably 330. So let me have a sort. So I've now had a bit of a sort out, and I've got all these that are the same, and if you just lay them they're all the same way round, it's much easier to see that they're the same, and we could count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. So we can guess that those are the 330, and when we see them all together it's much easier to see that they go orange, orange, brown. And if we look up resistor colour code, orange is 3, so that's certainly 3, 3 something or other, and I think brown is 4 zeros. And what are we actually looking for? Oh, hopefully brown is 1 0. So those are those, and then it just leaves these 2. Well, I happen to know, because I just happen to know, but 1 megohm has got a green in it. And what are we looking for? One is 1 megohm and the other one is 10k. Well, not sure which is which, so I'll show you another way of finding that out. And here it is. I've got it hooked up to the multimeter, and the multimeter is switched on, and it's set to a range, and I was expecting this one to be 10k, so I've set it to the 20k range. If I set it to the 200k range, it says 10. If I set it to the 2000k range, it says 0.1. But if I set it to the 20k range, it says 10 and a tiny little bit. So that's good news. Now let's see if we can see what colour it is. Let's unhook it. So we now know that it's 10k. But I also bought the other day this rather cool resistor kit. It's got dozens and dozens of resistors, and on the back it's got the colour code. So if it was 10k, it should start with a brown and then be a black. That would be 10, and then orange would be 000. And can we see, well, what did I say? It's going to start with a brown. Yes, it's pretty difficult to see, but brown, little tiny difficult to see, but anyway, it does. It goes brown, black, orange. So that's 10k. So before we get it muddled up with anything else, I think I'll take the board and I'll bend its legs around and poke them through the 10k hole. And resistors aren't polarized, so it doesn't matter which way around it goes. I just poke it through the hole and bend the legs back, and there it is. We see, yes, there it is, nicely in place with legs bent back so that it doesn't fall out. Which means the other one that's an odd one out must be the 1 megohm, but I'll connect that up to the meter just to see. So I've got it connected up, and it says 981, which is also almost 1000, and I've got it set to the 2000k ohms. So a k is 1000, so this is 2000,000, which is 2 million, so this is the 2 million range, and it's nearly 1,000,000, so that's the megohm, plus or minus a bit, and in general with these resistors they always are plus or minus a bit, so that is definitely the megohm resistor. And let's just disconnect it and see if we can see its colours. Going back to my little book here, down the bottom is actually pictures, and again I don't know if you can see it, but it would be brown and black and green. Of course that would be 5 zeros. And is this brown and black and green? Yeah, probably. Really is difficult to tell. But given that we know we only had 2 that weren't 330, and we know that that's not one of them, so we can put the other one in here. So bend its legs round and pop it through the holes like so, and bend its legs over, and we're done. So that's that one nice and neat. And now to save the boredom of watching me do that with all these other little ones, I'll turn the camera off and do them. So here's all the resistors in place, and an interesting little thing to be learned here. We know that if we want to wire up an LED without it going bang and releasing the blue smoke, we need a resistor. And so one of the questions we often ask is, what value resistor should I put in? Well, this resistor here, 330 ohms, is for the LED which is going to go in that hole. Not going to go in. Okay, so that resistor is for that LED. There's going to be another LED there, and there's its resistor. This LED is for the light dependent resistor. This resistor is for the power LED, which is going to go in there. And then there are 8 resistors here all around the place where the 7-segment display is going to go. And you think, what's that about? Well, the 7 segments are individual LEDs. So why are there 8 resistors? Well, because there's a decimal point as well. So there are actually 8 LEDs in here, and there are the 8 resistors for them. So if you ever think to yourself, I wonder what value resistor I need to put in so an LED doesn't blow up, think of the danger board, 330, 330, 330, 330, 330. Clearly 330 ohms seems to be a good value for little LEDs like this. So there we go. I'm going to take that out for now. And now I'm going to solder those, and you don't really need to watch that because that's a bit like watching paint dry. So I'll take away the video and get on with it. Okay, so that's soldered all those in place, and looking on the other side, it's reasonably neat and tidy. Not the tidiest in the world, but not bad. My soldering iron, this American soldering iron, is a totally rubbish soldering iron. I think it costs $3.50. My soldering iron back in England cost about £40, I think. Call that $60. This one's getting worn out, it's not sharp at the end, and blah blah blah. Anyway, also my side cutters here are very sort of big and chunky, but they're not as neat and precise as the ones I've got back in the UK. But good enough. So the next part that we're going to put on, it's this little switch. And you come across these switches all the time, and there is something that nobody ever explains, because mostly when you've got a switch you expect to see 2 wires coming out of it, but there's 4 wires coming out of this switch. And interestingly, I've never come across anybody anywhere who explains what it is that's switched, because there's only one switch. So if you were looking at 4 wires, you could think, well, maybe it's those 2 and the electricity does or doesn't go that way, or maybe it's these 2 and the electricity does or doesn't go that way. And if we had 2 switches, well, one could be that way or one could be that way and the other one, but there is only one switch. And the next thing we need to know is, when you switch it, does that switch it on or switch it off? So normally when it's just sitting there, is it off or is it on? And when you press the switch, it clearly goes the other way, but is that off or on? So I'm just going to set something up and then we'll see. Okay, so I've got my multimeter here and I'm going to switch it on. And I'm going to put it somewhere in the resistance range, somewhere in the middle. And all we're really concerned with is there a current flowing or is there not? So at the moment, the meter's not connected to anything and it says 1, and if we connected it to itself, it says almost 0. In fact, there it goes saying 0. So that's 0 ohms, which means no resistance, which means it's absolutely connected. And that's an awful lot of resistance. One of the things I wanted to say earlier when we were measuring the resistors is it's really important to clip them and not hold them, not because you're going to get an electric shock. There's such a small amount of electricity you wouldn't even feel it. But what I want you to see is, oh, not going to show now, oh, because I've got it too high. Let's turn it down a little bit. Is if I just get hold of these, come on, don't let me down. Show what I want to show. Oh, it's not going to show. Alright, well, what I want you to show is that sometimes when you hold them, what you get is a measurement, because it's kind of measuring you. Anyway, we were going to do something with a little switch, and here's the little switch. So what I'm going to do is if we put it down here and look at it, so there's kind of two legs on one side and two legs on the other side. So the question is the switch between the two legs that are on the same side, or is it between the two legs that are on the opposite side? Well, let's have a look at the same side first of all. I'll take my little alligator clip and clip it onto that leg. Clip this one onto that leg, and the meter hasn't changed at all. So let's try pressing the switch. Oh, there it goes. Now pretty much down to 0 ohms. So what we're seeing here is that the little switch is a switch between the legs on the same side, and when you're not pressing the button it's open, there's no electricity flowing, and when you press the button it's closed, and so there is electricity flowing. But what about the legs on the other side? Well, let's take this off and turn it round and connect it up, making sure they don't touch, and it's the same. So the little switch is effectively, it's two switches. It's a switch between those two and these two. But what about like this? Come up. Well, those two are connected together, and connect that up, and those two are connected together. So it's one switch, and it switches between the legs that are on the same side, and it's not polarized, so it can go in any way around. So I've been wanting to do that for ages because it's always puzzled me, but anyway, so the little switch is going to go in here where it says reset, and we press it in and make sure that it's nice and flat down on the board, and then I'm going to solder the other side, and then after I've done that I'm going to put in the chip, and here is the chip, and I need to take it out of its bag, one moment. So here's the chip out of its bag, and one thing to notice about chips is that they've always, if you look at them carefully, got a little dinge one end. I don't know whether you can see it here on the camera. Yeah, I can just about see it in the viewfinder. There's a dinge here, and if we look on the board you'll see that there's a dinge there, so clearly the chip has got to go in that way round, dinge to dinge, and this will be a bit fiddly, but let's see if I can do it on camera. So one set of legs have gone in fine, and now I'm just going to kind of ease these up with my rather broken thumbnail. Come on, in you go. What I'm going to do is I'm going to put this on the table and just press slightly to bend all the legs in, and if you see they're all kind of pressing a little bit now. I might have done it a bit too much, just do a little bit on the other side, check that I've got the dinge in the right place again, and have another go. Oh, I think this is going to be easier. Yeah, there it goes. So that's got that in nicely. We can look underneath and see about the same amount of daylight underneath, and see all the pins are sitting through there nicely. And this is called a shift resistor, and what this is for is there are 8 LEDs here, which means we need 8 pins on the Arduino to drive it, but we'd run out of pins at that rate. So what I want you to do is I want you to think of a line of soldiers all lined up, one in front of the other, walking along, one in front of the other, one in front of the other. It's a long thin line, and what this does is those soldiers, which are electronic signals, come into here, and we only need one door for them to come in through, and when they get in there they stop, they turn to their right, and then they march forward, and now there's 8 of them in what we call line abreast, so they would need 8 doors to go out of. So this is a way of connecting a signal to the Arduino and only using 1 pin, but actually driving 8 signals from here, and that's what the shift register is all about. So now I'm going to solder up the shift register and the reset pin, and then I'm going to do these other buttons here, and then I'll come back to you. Well, that was yesterday afternoon, and it's the following morning now, and whilst I was soldering, I put in 1, 2 and 3 LEDs. I think we'd already put that switch on, and the thing that right at the beginning I said was a transistor isn't, it's a temperature sensor. And this little thing labelled LDR, LDR stands for light dependent resistor. It's a light sensor. So this will tell us how bright the light is, and this will tell us how warm things are. I've put the buzzer in. I've put the 7-segment LED display in. And about the only things that are still to put in are the sliders and the headers. I'm quite pleased, it all looks quite nice, neat soldering on the back. The first time I made one of these, I made a mistake, not a mistake in how it worked afterwards, but a mistake on how easy it is to put together. And the thing that I did wrong was I put these in first, and here's the rule of thumb: put in the lowest things first. So the lowest things were the resistors, because when you put all of those in, you can then turn the board upside down and put it on the table, and they won't fall out because it will be resting on the resistors. And then the next thing we put in was this switch, because that was the next highest thing. And we put in the chip, and we put in the little capacitors here and here, and gradually went higher and higher, so that as you put things in and you turn it over and put it down, it stands. Now the next things that I'm going to put in are these headers, and these can be really complicated because the whole idea of the headers is that they provide plugs to plug into a board that's underneath, and they provide sockets for a board that's going to go on top. This is the whole idea of the Arduino shields. And I'm just looking at all my bits here. Here we go. And what we find is that there are 2 8-hole headers that go on that side, like so, and 2 6-hole headers that go on this side. And as I say, we can't bend the pins over because the whole idea is that it's going to plug into something else. But there are 2 problems here. If we're not going to bend the pins over, then when we turn it over to solder it, they fall out. That's the first problem. And the second problem is that when you put these into the holes, they wobble. Let's look at it sideways on. That's what I'm doing here. It wobbles, which means the pins underneath wobble. And if it's all going to line up nicely so that the things on top will plug in and it plugs into the things underneath, it needs to be absolutely perfectly upright. Well, there's a trick for doing this, and I'm going to turn off the camera, set up the trick, and then we'll see what it is. Now, I've been working on my animatronic bot, Benny, and Benny originally came with an Arduino and this joystick, and the joystick plugged onto the Arduino, and the buttons were used. This one switched it on and off, this one made his mouth work, this makes his eyes go one way and the other way, and these were used for recording, so that you record what Benny did and then play back what you'd recorded. Trouble is that those movements are recorded inside the Arduino, and the Arduino doesn't have very much storage. It has about 2,000 bytes, which is nothing at all. So I'm inventing something new and a bit special. So I bought this board here, I don't know whether you can see it, you'll see it better in a minute. And this allows us to have an SD card, and I've got a 1 gig micro SD card in there, which means we can now record an awful lot more, and I'm still writing that code. But let me turn the camera off for a minute. Oh no, I can do it here. Let's take the joystick off like so, just touch the hot soldering iron, and let's take the Arduino off like so. And now what we've got is a board that's got pins both sides. Oh, that might not be able to do what I want to do here, but let's give it a try. So if I take my headers and I plug those in there, and I plug those in there, and I plug those in there, those in there like so, and then I take my danger shield, and so in real life this would be going on top of the danger shield. So I'll plug those all in through here. This might be more complicated than I can do this way around, so let's try doing this. So I put the headers into the danger shield where I'm going to want them to be. Like so. It's quite difficult to video because I find myself looking past the video camera and then I don't see whether the video camera is picking up what we want it to see. But now if we plug those into there and these into here, this is all a bit fiddly, but it's going. There we go, it's in. Now, 1, 2, so it all just came out. It's all but there. Come on, in you go, little pins. There we go. So now when I turn this upside down, getting ready to solder, these are perfectly in alignment and they won't move, and it sits there and it's just waiting for me to solder. Perfect. Which I'm not going to do on camera because it's too difficult. Thought I'd try turning the camera around the other way and just doing a bit of soldering. It might be instructive. Let's see if we can zoom in. Right. So what we're doing here is put the soldering iron against the pin. When you're soldering, you shouldn't really melt the solder against the iron. You should use the iron to make the work hot. And then, so in this case we're using the iron to make the pin hot, and we're pressing the solder against the pin. We're aiming to see nice little dots of solder covering these white circles. Come on. There. So that's the pins soldered in. Let's zoom out. On camera, and we can take this board off of there because that's nothing to do with the danger shield, but there we are, they're all in nicely. I'm going to stop the camera and turn it around so it's where I can see it. Okay, so here we are, the headers soldered in, and here is one of Harold's BE boards, and we can see whether or not it plugs in. And the answer is yes, it does. We're in a little bit of difficulty. What's going wrong here? That's better. There we go. It plugs in. Sometimes with these headers you'll see there's a couple of pins spare, as there are there, and if we look here we can see that these buttons just kind of foul that power socket. In fact, actually, if I just press down a bit, they'll bend in. Could do a slightly better job of soldering those or trimming them or something, but anyway, that works fine. If you try and plug the danger shield in to an Arduino, it has a problem because of this Ethernet socket which is sitting up, and when we go and plug it into an Arduino, oh, actually it's not too bad. Sometimes it fouls that socket. If you sort of peer under there, you can see that one of the metal pins of this switch is touching that. And sometimes if you watch videos of people doing things like this, you'll find that they've put some tape over there. But what I will do is I will go under here. Where are we? You can see some of these stick up, so I'll squash those down and make sure they're not sticking up. So the only thing I've got left to put on is the sliders, so I will do that. And there you go, like that, and we can indeed just bend those over with our fingers just to make sure that they don't drop out before we solder them. 1, 2, and 3. So, and they're not now going to drop out. Push all the sliders up to the same end so that it sits firmly. I wonder if I can solder this on video. It's going to take quite a lot of solder. And you see when it starts to flow, if it sits there, just sitting there as a bubble, not a good deal, but that looks like that's soldered in, and there's some white underneath, so I'm going to try and get to that. Come on. If it's a big lump like this, it takes a while for the heat to get through. Come on. There it goes. Oh. I don't know where that solder went, it melted. Come on, solder. I'm sure this is good enough, but I just want to get the remains of that white bit. This is going to be boring, so I'll do the rest of it off camera.